Welcome back. So now that we've gotten past the obligatory Hello World demo, it's time to start laying the foundation for real programming in Python. And the building blocks for pretty much any computer program are individual pieces of data, such as numbers or strings of text characters like a person's name. And in the parlance of programming, these pieces of data are typically referred to as values. Now further, every value in Python has a type, which is basically a classification for, well, what type of data it is. For example, a number with no decimal component is called an integer. Now the official name for this data type in Python is just int, obviously short for integer. Conversely, a number with a decimal point is referred to as a floating point number, or just a float in Python speak. And then there is the string data type, represented as str in Python, which encompasses sequences or strings of characters. These are commonly names of things, in which case the characters are mostly letters, but they can also consist of numbers. Think of an identification number, for example. You probably wouldn't try to perform a mathematical operation on this kind of number, like multiplying it by 2, and yet it may consist entirely of numeric digits. In fact, as we'll see, a value's type greatly impacts the kind of programming operations, like multiplication for example, that we can perform on it. Now it's worth noting that there are many other data types besides these in Python, many of which we'll encounter throughout the rest of the course. But these three are arguably the most foundational and the most common. So now, before we go, let's do some very basic programming with these different types of data. So back in Replit, my first item of business will be to clear the shell here to give us a clean slate. Now to do that, I can simply close this tab that our shell currently lives on, and then to start a new shell, I can simply scroll down this list of the various widgets Replit gives us to interact with it until I find the shell, and just click that. And just like that, we have a clean slate. So back in the Replit shell, I'll first type Python to tell the shell that I want to issue Python commands to our little virtual computer in the cloud here. And now, for our first very basic example, I'll print an example of an integer, the number 42, which some contend is the meaning of life itself. So I'll just say print, and then inside of those parentheses, 42. Okay, so I don't feel especially enlightened even after printing 42, so I'll move on to printing a floating point number, 123.45. Pretty much the same thing as before. And you'll find that for many, but not all purposes in Python, integers and floating point numbers can be handled the same way. Now where things get a bit more interesting is with strings. So now let's try to print a string. Say the sentence, "This is a string." So we'll start by trying to do that exactly the way we did with our integer and floating point example. And right away, we get our very first error, which I can assure you is not a bad thing. Professional programmers get errors in their code all the time. But what separates the pros from everybody else is how they respond to these errors. By calmly reading the error message, reviewing the problematic code, researching the issue if needed, and finally fixing the code. Not, as you might imagine, by losing confidence, getting frustrated, and possibly sending the computer through the nearest window, although this can be very tempting at times. So in our case here, this particular error is pointing to the text that we fed the print function, and telling us we used invalid syntax, which is really just a fancy way of saying we didn't follow the rules of the Python language, much like if you forgot to put a period at the end of a sentence in a human language. So what's wrong with our syntax? Well, if you recall back to when we printed "Hello World" in the previous video, we wrapped the characters of that phrase in quotation marks. And that, as it turns out, is how we tell Python that what we're referencing is actual data. A text string, namely, and not the name of some feature or function within the Python language itself. For example, imagine if we tried to print the word print. Python wouldn't know whether we're talking about the word print or the Python print function. Now, this sort of confusion isn't a problem with numbers like 42 and 123.45. After all, Python probably isn't going to have some built-in function or reserved word called 123.45. And as such, quotes aren't necessary for numbers. Unless, of course, you want those numbers to be treated as a text string. More on that in a second. So back to our current example, let's try adding those quotation marks around the text string we're trying to print, and then rerun our code. And now, with our quotes added, the correct value prints to the screen. Now, it's worth noting that you can actually use single quotes or double quotes to mark the beginning or end of a string. So, for example, if I wrap this text string in single quotes instead of double quotes, our example still works. However, if you want to include a single quote in the body of your string value, like, for example, in a contraction such as the word I'm, you'll need to stick with double quotes. So to see what I mean, let's go ahead and try to print the string "I'm a string too," but wrap the text in single quotes. So this confuses Python because it thinks that second single quote after the I represents the end of the string. But then we have more characters and a lone orphan single quote at the end. But now if we change those single quotes to double quotes, everything works fine. And as you might expect, this same principle works in reverse too. If your string includes a double quote, you'll want to wrap it in single quotes. Now finally, let's consider what happens when you print a number. Almost like we did before, but wrapped in quotes. Now the output looks the same as when we printed numbers earlier, but behind the scenes there's a crucial difference. Because of the quotes, Python looks at this number the same way as it might look at a person's name. To revisit our earlier example, this kind of string is like an ID number, a sequence of characters that just happen to be numeric, as opposed to an actual number you can perform calculations on. We'll dig deeper into how to determine data types programmatically with Python, as well as the kind of programming operations we can perform on each data type a little later on. But to do all that, and really to do anything of any significance in Python, we'll need a little bit of help from the Python language. And probably the single most efficient mechanism Python gives us to tap into its vast functionality is with Python functions. Now, we've already seen an example of a Python function with the print function, but we haven't yet dug into the mechanics of how functions work, so we can take advantage of the vast array of other functions Python gives us. But that's going to change starting in the next video. I'll see you there.